Aloha and welcome to the second lecture for Introduction to Philosophy of the Social Sciences. My name is Kanoa Merriweather, and let's get this thing started. So the reading again is the Rosenberg article, What is the Philosophy of Social Science? For this part of the lecture, you're going to want to read, have Thomas Kuhn's, or rather Frank Pahara's synopsis of Thomas Kuhn's Structure of Scientific Revolutions read, because we're going to talk about that. And then you've got William of Ockham, Isaac Newton, and Thomas Kuhn in your 100 Essential Thinkers by Philip Stokes. So, Rosenberg talks about the issues that positivism has had to face and that sort of thing, and we need to talk a little bit about positivism. Positivism is a philosophy basically that is a very strict form of empiricism, yeah, and that's one that most natural science has been based on. It says that the only authentic knowledge is scientific knowledge, and so a positivist rejects any metaphysical explanation or any religious explanation, anything other than something that is a scientific explanation that is based on reason and logic and those sorts of things. A positivist believes that scientific knowledge can only come from positive affirmation of theories through the strict scientific method, that we must prove theories to be true, not falsified, right? So Karl Popper would not be a positivist. That a positivist believes basically that through strict scientific method, we can develop new scientific knowledge, yeah? And that method is empiricism, it's observation and experimentation. So positivism states that science can rise above superstition and rise above religion and myth by specializing in the description and analysis of observable phenomena, and that process will lead to the discovery of natural laws. So positivism has the feature of the belief that science is cumulative, right? That we started with the Greeks, and we've gone through the Middle Ages, and all these philosophers and all these scientists have added to our knowledge base, and that most of the time we've got a cumulative, for fairly linear and continuous process in science. Although there is a belief that sometimes science incorporates new ideas that are discontinuous, there's still the belief in positivism that science involves the idea of one unified world. Yeah, the idea is basically that all science is studying the real world, and therefore there's a unity, because there is a unity in the natural world. Yeah. So when we get to the point of sophistication, of the best of the furthest sophistication, we're going to wind up with not all these separate sciences, but one science about one real world. Yeah. So for positivists, they feel that natural and social sciences can coincide because they're both studying the natural world, and that is a singular nature. Yeah, so we don't need to argue between, that one is better than the other, that sort of thing. They inform each other because they're both studying the same thing, which is the natural world. So positivism is the intellectual inheritance, basically, that has been handed down for generation upon generation in science as an idea about what is good knowledge, what is truly scientific. One of the key features that gave positivism its strength is its linguistic focus. Yeah, it says that science is not just a process, but it's also a product. That product is a linguistic or numerical set of statements that it's saying basically that it's not just us asking questions about the world. It's also us saying this is what I found, and we do that, and so we state things in the proper grammar, the proper linguistic way, or using the correct mathematical statements. Yeah. So positivism also has a concern with axiomatization, right? Which means basically that they want to demonstrate there is a logical structure, a logical coherence of each one of the set of statements that make up our scientific body of knowledge. Yeah. So the idea is that every statement of scientific fact or belief or hypothesis should be verifiable. We need to be able to test every single scientific statement. And so if we cannot verify it, then we should be able to falsify it. So in science, logical positivism was a widely accepted perspective. Yeah. And positivism advanced this theory, this notion of what we call the deductive nomological or covering law theory. And that is basically the idea that when we want to explain any event, we have to understand those laws which govern the event. And once we identify the conditions that produce that event, we can predict that those conditions will produce the event again. So, for logical positivists, explanation and prediction are interwoven. If we come up with a strong enough explanation, the ability to predict will already be within that explanation. So, the perspective, the history of science from the positivist viewpoint was one of specific theories being incorporated into larger, more fundamental theories as time goes on, right? That we're making specific theories. The Greeks made, these basic observations and came up with their educated hunches about what was going on. And we've been building on those and incorporating those into broader, more fundamental theories about our world, bigger sorts of laws and things, things like the theory of gravity and theory of evolution and things like that. These are broader, more fundamental theories than just the theories that talk about what happens when a apple falls or when a ball rolls down an inclined plane. So, to give you an example there, the positivists would point to, sort of this progression between Galileo's theory of terrestrial mechanics and Kepler's planetary orbits, how they're both explained by Newton's laws of motion, right? So these are Galileo's theory of terrestrial mechanics is a specific theory, right, about how the planets work, how orbiting works. Kepler also had his own specific theories about planetary orbits. Both of these theories are subsumed and explained by Isaac Newton and his laws of motion. Yeah, so we're seeing more specific theories being incorporated into broader, larger theories. And then, so Newton has his laws of motion that are then incorporated by Einstein's work into his theory of relativity, which covers even more material in the universe. So positivists believe that science is an accumulation of increasingly precise explanations and increasingly powerful predictions about our world. We develop these increasingly precise explanations and predictions via incorporation of our older insights into the newer theories. Yeah. So according to positivists, progress of science is the logical derivation of one axiomatic system from another. And so what we're talking about here is being able to use these very specific theories, such as the theory of terrestrial mechanics and theory of planetary orbits, to develop the theories of laws of motion and Newton's work, right? And the idea being that this is a cumulative process, that we go through the decades and the centuries building up all of this information, building these theories and understanding these theories better. Yeah, and that there is no logical break in these theories, that they are all cumulative, they're just increasingly precise, and we incorporate the older insights into our newer theories, but they all logically match each other. That's the positivist perspective. So positivism held sway for a very long time, until roughly the 1900s, when folks started to deal with unobservable entities and processes in science. And we're trying to use the philosophy of empiricism to study our world. Well, if empiricism says that we must trust our senses and observe, the thing under study, well, how do we observe electrons when they're too small for the naked eye to identify them? How do we observe a process or a power such as magnetism that's invisible? Yeah. How do we observe things that are so tiny, such as genes inside each single cell? Yeah. So we cannot directly observe these things. Well, that's a problem for positivism because it says that only directly observable information is scientific, right? So they came up with a solution which was to test indirectly, not via observation of the things that you're testing, but observation of the implications of the untestable event. So we can't see magnetism. We cannot see whether or not a block of iron is magnetized or not, right? But we can test whether it attracts or repels another form of metal. And that outcome, the implications basically of when you put this one piece of metal down and it draws another piece of metal to it, well, that tells us that there appears to be some magnetism here, yeah? But the problem now is that for whatever we're seeing, we can come up with any number of explanations for that observation. And no one, single theoretical statement directs our experimental process. We need some system of theoretical statements that work together to guide our observations. How do we know which observations are meaningful and which observations aren't? And how do we know which guess to use when we're looking at, the action of these magnets working? How do we choose which hypothesis to apply to say, I think what's going on here is this? Well, that's a problem that we call the underdetermination of theory by evidence. Yeah, basically the problem is this. For any event, whether it's a rock striking a window and the window breaking, or the election of a certain politician to a certain political position, there are infinite explanations for that event. Yeah. So, like, for example, again, I mean anything. Whether or not it rains today. Yeah, there are infinite explanations for that. The question is, which explanation do we choose to support? Well, the answer, or at least a guiding principle, came to us from a Franciscan friar who lived back in the 1300s by the name of William of Ockham. He was a Franciscan friar who was devoted to a life of poverty. You remember the Franciscans believed that Jesus Christ did not own anything, and that Christians should follow his example by devoting themselves to a life of poverty. So not only was he a deeply religious individual, he was also a philosopher and a scientist. And what he devised was a principle of parsimony that helps us to decide which explanation to choose when we're trying to explain an event. That principle of parsimony is now known as Occam's razor. And it basically says that when you're trying to explain an event, you should always opt for an explanation that gives us the fewest possible number of causes, factors, or variables to take into account. Another way of saying that is that if there are two equivalent theories or explanations for an event or an observation, and all other things are equal, the simplest explanation, the simplest theory, is the one that we should choose. That's the one that we should apply. So Occam's razor is a vital methodological principle of science. It is vital because that is one of the primary activities of science, that we are formulating theories. We are selecting the most promising theory based on an analysis of the collected evidence. To do so, it requires some method of selecting between the theories that fit the evidence. So Occam's razor allows us to say, well, even if we have two theories that fit the evidence, or three theories, or four theories, we should look at these theories in terms of which is the one that is the most simple. Yeah. So let's say you wake up one morning and you look out your window, and the palm tree that used to be standing straight and tall in your front yard has been split in half, and the top half of the palm tree is lying on the ground, and it looks like some sort of violent episode occurred to break that palm tree in half. Well, so you can come up with any number of theories as to what happened, right? And of course, you can use your observation, to say what is this? How did the break occur? What does the break look like? Is it a clean break? Is it a rough break? That sort of thing. And we can come up with some possible theories. One possible theory, is that maybe somebody came and chopped the tree down. Yeah. Another theory is that maybe the tree got struck by lightning. Yeah. So with Occam's razor, we want to apply Occam's razor. We'd look at the issue and we'd say, well, one of these theories here requires a lot more assumptions. Yeah. So the theory that someone would come and chop down my tree in the middle of the night, well, we've got to then assume that someone would have the ability to do so, and would do so and just leave the tree lying here. Yeah. The other possible explanation, that a storm occurred last night and there was lightning. Well, if we had evidence, let's say that it rained last night, and if we had evidence last night that there was a thunderstorm, well, then there could very well have been lightning, and it could very well have hit the tree and caused the tree to split. Yeah. So the issue is that we use Occam's razor as a principle to help us to choose among all of these theories. However, the fact remains we must choose a theory, and it's the issue of how we choose that theory that is the problem. Even if we go on the most parsimonious theory, there are also other factors that influence that selection. And this is what Rosenberg means when he talks about problems for positivism. He says that basically the problem came to the fore that observational evidence can contain several alternative theories, and none of these theories might necessarily have greater strengths than the choice upon which we base our decision, yeah, is non-empirical. We're choosing a theory not based on empirical factors, but probably on other factors. Factors such as our values, factors such as our biases, factors such as who is funding this research. Yeah. So once we came to that sort of conclusion that science is not an objective, process, but is actually a subjective process, that started to close the coffin close the door on positivism as the leading philosophy in science. We saw, once that sort of issue came out and people started talking about it, we saw the growth of the psychology of science and the sociology of science. In the 1970s, we see all of a sudden journals starting to arise, and people starting to conduct studies into the sociology of science. And so the final nail in the coffin for anyone who says that positivism or empiricism is the be-all, end-all of science is the fact that science is driven as much by psychological factors, by social factors, and by ideological factors as it is driven by logic and empiricism. Yeah. So an obvious example, the science in Nazi Germany that said that blonde hair and blue eyes makes the person a better person. That a person with blonde hair and blue eyes is smarter, stronger, faster than a person with dark hair and dark eyes. Yeah, that was based on ideology rather than logic. And Nazi scientists, they were out there, they were championing this, man. They the 1938 Olympics or I think it was the 32 Olympics, but basically Jesse Owens went to Germany and went to Berlin, and he won several races, won the Olympic medal, and this was a huge problem for Nazi scientists, because they were saying that the Aryan race, that the blonde-haired, blue-eyed people are better in every single way. And, here is a case of falsificationism. Here's Jesse Owens coming and showing them that they're absolutely wrong. Yeah. Another example of the lack of empiricism in science is the notion of gender. When you look at the history of science, it's the history of rich white males, and we cannot argue that fact. It has been the history of rich white males as far back as written history goes. It's only been the past 2 centuries that females have been allowed and have been able to break through into the realms of science, and thank God that they have, because they've been able to provide amazing insights, truly spectacular theories that make amazing sense and have furthered science. So thank God we've gotten beyond the notion of gender, of science being a solely Caucasian male endeavor. So if we come to this point basically in the history of science, that science, we cannot argue that science is an objective, purely logical endeavor. Science is a human endeavor. It is a human process, and it is therefore it is subject to the exact same foibles that every other human process is subject to. We've got to deal with our own values. We've got to deal with our biases. We've got to deal with ethnocentrism. We've got to deal with subjectivity. Yeah. So if science is not a purely logical and objective endeavor, then what is the alternative? What is science? Yeah. Well, and what is the title for this slide, Rejecting Prediction for Intelligibility? That's saying basically, what should science be? Should it be prediction, or should it be something else? For social sciences, we say it's not necessarily prediction, it's understanding the meaning, and that's what intelligibility is. So we get to that point basically because we have a genius named Thomas Kuhn. Thomas Kuhn did an amazing work on the history of science, and he revised our understanding of the way that science progresses and what science is in such a strong and forceful way that it's become a one of the foundational texts in modern philosophy, and that text is called The Structure of Scientific Revolutions. So in that book, Thomas Kuhn eloquently challenges several key aspects of the positivist view of science. Thomas Kuhn argued that rather than cumulative progress, science has instead been a succession of incompatible general theories or paradigms or perspectives, and that it's a succession with one incompatible perspective replacing the next. So Thomas Kuhn, who passed away in 1996, unfortunately, is hailed as one of the most influential philosophers of science in the 20th century because of his book, The Structure of Scientific Revolutions, which is still one of the most cited academic books of all time. Before Thomas Kuhn, the standard view of science said that there was a cumulative addition of new knowledge in terms of the application of the scientific method. But Kuhn comes along and he says, no, science did not develop in this cumulative, uniform, linear manner. Science has periods of stable growth that are punctuated by what he called intellectual revolutions or paradigm shifts. The successive transition from one paradigm to another via revolution is the usual developmental pattern of mature science. That is Thomas Kuhn. That is his key insight. What he's saying is that science has not been this cumulative growth of knowledge that starts with a seed and grows into a tree. He says, no, science develops through these 2 phases. Its normal phase and its revolutionary or its extraordinary phase. These revolutionary phases, these periods of paradigm shift, are not merely periods of accelerated progress. He says that they're called revolutions because they differ qualitatively from normal science. He says a scientific revolution the revolutionary phase involves a revision of old data into the new scientific belief or practice. So, what is he saying here? He's saying that the way science progresses is by having new paradigms, new perspectives about the world that are initially rejected by science and slowly wind up overtaking and having to force science to change its perspective. So, for example, the sun-centered solar system, it took centuries for human beings to accept that the Earth is not the center of our solar system. As a matter of fact, many people went to their death in the medieval ages because they wanted to argue that what they observed did not match the teachings of the Christian faith. The Bible and the Christian faith said that the Earth and human beings are the center of the universe. But that's not what our observations told us. And it took a very long time until we were able to finally accept that the Earth is not the center of the solar system. Another theory that was initially rejected by mainstream science is the notion of warm-bloodedness in dinosaurs. When I was a child learning about dinosaurs, what I learned was that all dinosaurs were slow-moving, cold-blooded reptiles. Well, now we know that many of the dinosaurs that we used to think were cold-blooded were actually warm-blooded, and that they actually have descendants now that are birds. Another theory that was initially rejected by mainstream science, the germ theory of disease, the idea that people got sick because of tiny things that you cannot see, was initially laughed at. Another theory that was rejected is the theory of continental drift. For a long time, we believed that the Earth was basically came about with the continents set as they are. And, it's only been in the past century or so that we've come to understand that the Earth started out with one giant landmass that is split apart and slowly spread apart the globe to the shape that it's in now because of the tectonic plates. Finally, the theory of evolution was initially rejected by mainstream science. It took a long time to catch on and is still being challenged by folks. So these are paradigm shifts. And what happens is they start as an anomaly in the data. Normal science is going along saying that the Earth is the center of the solar system and it seems to be this way and so on and so forth. And then someone comes and says, I have this observation that doesn't fit with our data. That doesn't fit with our theory. Well, put that observation aside. That's an anomaly. Well, we get more and more of these observations that are anomaly, and as they build, all this contradictory evidence builds. And after a while, we cannot ignore it anymore, and we have to say, this contradictory evidence has to be explained somehow. And that's basically the avalanche of paradigm shift, where so much evidence is built that we now have to accept, or we now have to somehow understand our world as working from very different principles. Some of these paradigm shifts, for example, Darwin's theory of evolution by natural selection. We did not always believe in evolution. We believed in special creation, that God created man as a special organism on this planet. Darwin's theory of evolution showed that could not be true, that we were not put above all others. As a matter of fact, we had to fight and scrape and battle our way, and there was something else that wound up making us the dominant creature on this planet. It's not because God put his hand down and said, you win the lottery. And then the unification of classical physics by Newton, his work into a coherent mechanical worldview provided science with a notion and a paradigm that lasted for 5 centuries basically, and that was the paradigm of the universe as a mechanism or a clock. So his work shifted us from this idea that the world works based on the whims of God to this other idea that God set this mechanism in place that is the sun, the moon, the stars, the power of gravity, and all those other things, and that we have this mechanism that works the world, and we can understand our world by understanding that mechanism. Yeah. Another paradigm shift was a transition from Newtonian physics to the Einsteinian relativistic worldview. This notion, when Newton came out with his Philosophiae Principalis Naturalia Mathematica, he said that gravity is universal. Yeah, he said gravity works the same way everywhere. Yeah, Einstein came along and said, no, it doesn't. He said gravity works in part based on who you are and where you are. Yeah, and if you're at the edge of a black hole, then gravity is going to work very different for you than it does here down on the planet Earth. Yeah, and so these transitions, yeah, as you can see, are not cumulative. Yeah, as a matter of fact, they're contradictory. You cannot lay one on top of the next and say this one grows from that. As a matter of fact, what it is incomparable. Yeah, and this is one of the key insights from Thomas Kuhn. These paradigms do not build upon one another because they're comprised of irreconcilably different concepts. Yeah, these concepts are so different, there's no neutral basis to compare or translate between them. Right? So the concepts of the Earth being the center of the solar system and the sun being the center of the solar system, these cannot be somehow negotiated and melded together. Yeah, it's got to be one or the other. They're irreconcilably different. Yeah, either the sun is the center or the Earth is the center. You cannot say that it's a little of each. Yeah. Same thing goes with evolution and special creation. Same thing goes with Newtonian and Einsteinian physics. It cannot be both. It has to be one or the other. Yeah. So Kuhn says, wait a minute. What we've got are these paradigms that are irreconcilable. So how do we get this appearance of progress in science? Well, he says it's because every time we have a paradigm shift, yeah, the new generation of scientists who say, we finally got it, we understand now, it's evolution, it's not creation, yeah? They rewrite the history of their science so that the latest paradigm seems to be logically connected to its successors, yeah? And again, this is what we call reconstructed logic, yeah? This is not logic in use. This is not true objective reporting of the world. This is instead a cleaned up version of what we want people to understand and believe. Yeah? So, science is not necessarily objective and rational. There are times when science is subjective, extremely subjective, so much so that we are rewriting our own history so that it looks to be logical and cumulative. So, as I said, the Earth and the sun cannot both be the center of the solar system. Yeah? There is no translation between one view or the other. It must be one or the other. None of the observations supported Earth as the center of the solar system back when the heliocentric view was being challenged. The patterns could only be explained by saying that the sun is the center of the universe. Of our solar system. Newton and Einstein are not really compatible. Newton says gravity is constant. Einstein says it's relative. So Kuhn says we have this concept of progress as predictive success and objective knowledge. That concept is wrong. He says we have that concept because of the outgrowth of the success of Newtonian physics. Yeah. Newtonian physics was so successful at allowing us to predict and allowing us to use the natural world to our benefit, to create engines, to create technology that bettered our lives because it was so successful. We automatically accepted that's how all science should be, that all science should be empiricist, that it should all be based on the concept of predictive success. Yeah? But there's an issue here. Not all science is Newtonian science. Newtonian science is an extremely deterministic theory. The reason for that is because it assumes strict and exceptionless laws. Yeah, it's a theory of causal physical mechanisms that, of course, were required by Newton to explain why we see these patterns in the world the way that we see them. So, Newtonian physics has been the benchmark of scientific success. Newtonian physics gave us this idea that causality should be the ultimate explanation. Yeah, but Newtonian physics is no longer the the at the top of the pile in terms of science. Newtonian physics has been replaced by relativity and quantum mechanics, and these new perspectives now say that the world is not a big set mechanism, and it is not deterministic. The world is instead indeterministic. It is instead made up of things that can have dual qualities and characteristics. So, for example, we can discuss light in terms of it being comprised of particles. Yeah, light acts as though it is a collection of light particles, but we can also discuss light in terms of a wave, because it also has the exact same characteristics. Yeah, waves of light. Yeah. So if we want to say that light is one or the other, we're cutting off our nose to spite our face, because it's both. Yeah. So the notion of having one definitive prediction as a criterion for scientific success is a bad idea. Yeah, because if we want to predict the way that light works, we have to understand light being both particle and wave. So we cannot say it's one or the other, it's both. Yeah? So now, rather than the classic Newtonian physics that has all these definitive causal statements and deterministic statements about gravity works this way and it works the same way everywhere, we now have physics that is a set of statements of probability that is based on statistics. Yeah? Physics now, when you get to quantum physics and you're talking about the subatomic level, we have problems with even saying that we can identify where matter is. Yeah? It appears that matter can be in two places at the same time when you get down to the subatomic level. So even natural science, even the granddaddy of them all, physics, has to back away from that power and that notion of 100% proof of immutable natural laws. Now, natural science has to back away from that notion of strict laws that hold true 100% of the time. And if natural science is backing away from that, then why should social science be held to those same criteria? And one of the key differences that we can point to is that natural sciences and social sciences study very different kinds of things. Yeah? In the social sciences, we're looking at human behavior. So our explanations in social science are trying to explain, to give us an understanding of the meaning of that behavior. What we're doing is interpreting behavior. We interpret what people do to understand why they do it, the meaning. Yeah? So the explanations in social science have to deal with a much greater level of complexity. We're dealing with intentional action. We're dealing with human beings who have goals, who have a purpose, who have beliefs, who have desires, who have intentions. Yeah? So what we say and what we do are not equivalent to what rocks do. Yeah? It's not equivalent to studying the things in natural science, these things that have no intention, that have no goals, that have no purpose. So this is another level of complexity that social scientists have to deal with, that natural scientists are lucky enough not to have to deal with. And we can look at what explanations exist in social science. Human beings seem to have a general system of interpretation of human action that we label folk psychology. Yeah, we look at what other people are doing and we use our basic system of interpretation to tell us why they did it. Yeah. So we see a person drinking from a can, and we assume that they're drinking because they have the intention, because they have a state of thirst, and that they want to quench their thirst and no longer be thirsty. So they drink this substance, and it makes their thirst go away. That's folk psychology. We believe that we do things to achieve certain outcomes. Yeah. Again, we'll see somebody eating a slice of pizza, and we say that person is eating that slice of pizza because they are hungry, right? But we know that's not 100% accurate. Yeah, people can do things, the exact same behaviors for different reasons. One person might be drinking because they're thirsty. Another person might be drinking because they want to get a buzz. Yeah. So, what the person's drinking and their intentions for drinking it can be very different. Uh, People can eat not only because they're hungry, but nowadays people eat because they're bored, because they don't have anything else to do. So they pick up a pretzel, or they pick up a slice of pizza or whatever, and it gives them something to do with their hands and something to do with their mouth and that sort of thing. Yeah. Folk psychology is useful. It's extremely useful, but it's nowhere near specific enough to allow us to call it any form of social science. But we continue to use folk psychology. We believe, and it's generally true, that people seem to act because they have a certain set of beliefs and desires. And this paradigm that we have for predicting behavior, this is the best paradigm we've come up with so far, and we use it daily. If we know an individual's beliefs and desires, we can typically predict their behavior in some general way. Yeah. So if we know the person desires, let's say, to be wealthy, and that they believe that hard work is the road to riches, then we can predict their behavior. Will they study hard for this test? Will they stay late at work? We can predict they probably will, because of that knowledge of their belief and their desire. However, it's not a causal theory. The prediction that we have in folk psychology is just a byproduct of our desire to understand human behavior through interpretation. What we're doing typically is we're applying our own beliefs and our own desires upon someone else. That usually works, but it's not always correct. Yeah. So, folk psychology proponents, though, point to an increased knowledge and understanding of other cultures, not through scientific methods, but through our search for intelligibility, through the social science domain of anthropology, conducting participant observation, living in cultures, and learning the culture's system of meaning, learning its own folk psychology through participant observation. Yeah. So we come to this basic conclusion that there has been progress in social science. Social science has progressed. It's deepened our understanding of not only our own culture, but the notion of culture itself. We've been able to leave behind some very negative perspectives, such as moral absolutism, xenophobia, and racism, in part due to the efforts of social science. Yeah, and of course, I say left behind. We have not, of course, left xenophobia and racism completely behind, but we have no logical rationale to support them, and we hope that in time that they will slowly become extinct. Yeah. And that does it for this lecture. If you have any questions about the readings or what I've been talking about here, please give me a call or send me an email. And we'll see you on the flip side on the next lecture. Aloha.